Dear students, in this video we will discuss about PV and the PV diagram for the steam. It is PV diagram or the temperature volume diagram, including the critical state for the water. There exists an important state known as the critical state of the substance, which will be shown as in the figure below. On this TB diagram, you will see on this vertical axis, we are showing this temperature, and on the horizontal axis, we are showing the volume. And here you will see this is the line or the curve. You can see, so this is called as the saturated, this is called as the saturated liquid line. You can see this one. And this right hand side curve is called as the saturated vapor line. The point at which these two meets here, it is called as a critical point. Now, within this zone, you can see between the saturated liquid line and saturated vapor line, this is called as the wet steam zone. On the left hand side of the saturated liquid line, there exists the liquid zone only, and on the right hand side of this saturated vapor line, this is the superheated steam zone. So, how the water is converted into the steam? It is done at the different pressures. So, consider here we are taking the water at pressure 1 bar. You can see this line A to B, then B to C, and C to D. So suppose we are here at point A, we are having the water here at point A. It is at some temperature. When the water is heated, it follows A to B curve. And at point B, the temperature is called as a saturation temperature, at which the boiling will start. So A to B indicates the sensible heating of the water here. At point B, we are having the water, which is the saturated water. If we are further giving heat to the water, it will follow the line BC. And the BC indicates the phase change from the liquid to vapor phase, the gaseous phase. At point B, we are having the totally water, 100% water, but water is the saturated water, right? B to C, between B to C point, we are having the mixture of the water and water vapor. At point C, we will see that all the water has been converted into the steam. So at point C indicates, because it is lying over the saturated vapor line. So point C indicates the condition of the steam, which is the dry and saturated steam. If we further heat the dry vapor at this 1 bar pressure, its temperature will increase and the steam will become the superheated steam here. This is C to D indicating the superheating of the steam. Now, because we have started from the point A, from point A up to the saturation temperature, this is showing by this line. So this temperature difference showing by this arrow is called as the degree of undercooling. This is showing the degree of undercooling, means temperature below the saturation temperature of the liquid is called as this difference of temperature is called as the degree of undercooling. Similarly, the superheated vapor is at the temperature higher than that of the saturation temperature. So the difference of the temperature between the superheated steam temperature as well as the saturation temperature is called as the degree of superheat. Now here if we increase the pressure, suppose we are making or producing the steam at the 50 bar pressure. So we are following this line, that is E to F, F to G, G to H. The pattern is similar, but you will see this Fg is lesser than the Bc. So the latent heat part is decreasing. It means if we are increasing the pressure, the latent heat part is decreasing, but the sensor heating part is increasing. If we further increase the temperature up to 100 bar, it is following I to J, J to K, and K to L. This is showing the change of phase of the water into steam at 100 bar. Further, the latent heat is decreasing and sensor heat is increasing. If we further increase the pressure and following this M and O curve, then we are seeing that there is no heat given in the form of the latent heat because this curve is continuous. But if we compare with the other curves IJ, KL or EFGH, there is some break. The curve is curve breaks here between the JK, so it is showing the line which is indicating the latent heat. The point N is called as the critical point and it is corresponding to the pressure which is the TC equal to 221.2 R. It is the critical pressure. On further increasing the pressure more than 221.2 R, it is showing the line or the curve PQ which is the 400 R. It is the supercritical condition where the liquid directly converts into the gaseous phase without giving or without boiling any heat in the form of latent heat. So this we have done or this we have taken for the 1 kg of steam. Now this is the curve only for the PV diagram. We are also having another diagram which is called as the PV diagram, pressure volume diagram here. So on this vertical axis we are having the pressure and on the horizontal axis we are having the volume. So this is called the PV, so the pressure volume diagram. Here, if we start from this point, which is again called the critical point, the left-hand side curve, this bold line indicates the saturated liquid line, and the right-hand side, this bold line or bold curve is called as the saturated vapor line. Between these two curves, there is the wet steam zone. So this is the mixture of the water and the steam. On the left-hand side of the saturated liquid line, this is the liquid zone. We are having the only water, which is the unsaturated. And on the right hand side of this saturated vapor line, this whole area is the superheated steam zone, only the gaseous phase, the vapor phase. Now, here you will see between these two curves, we are having the curves showing the by the dashed lines. This is one dashed line. Here this is also the dashed line or the curve. So these dashed line or the curves between the saturated liquid line and saturated vapor line is called as the quality lines or the dryness fraction lines. Quality lines or dryness fraction lines, which indicates the dry condition of the steam. If the lines are closer to the dry saturated vapor line, its value will be closer to the dry vapor because the dryness fraction for the dry vapor is equal to 1 and dryness fraction for the saturated liquid it is 0. So the dryness fraction indicates what is the dryness of the steam. The value will be 0 0.9, 0 0.95, 0 0.8 closer to the this point D. And the value of the dryness fraction is 0 0.1 or 0 0.2, it is closer to point F. Now in this curve we will see there are some constant temperature lines which is showing the constant temperature here T equal to C. It's another line T equal to C. Here the pressures are different and these lines are the isotherms. So the line which is passing through this point B is called as the critical isotherm. Critical isotherm, temperature constant. You see another line also the isotherm, showing the constant temperature. You see another line at the lower pressure, again known as the isotherm. So this is the constant temperature line. If we are going rightward, we will see the pressure is increasing. This line and this line and this line, constant temperature line. If we are going the right side, then we will see pressure is increasing. So when the pressure is increasing, there's less amount of the heat is given in the form of the latent heat. So if we see here from this point D, E, and F and G, if we start from the point D, at point D we are seeing the steam is the superheated steam here. But at point E, we are seeing that the steam is the dry steam. So if we cool the superheated steam, then definitely at the temperature will decrease. But because this E2D is a isotherm, so uh, the steam at this pressure D, which is the lower pressure, it is a superheated steam. We consider here correspond to this point D, the pressure is lower, but at point D, pressure is higher. But because D2 is the isotherm, so at the lower pressure, the steam which is dry vapor at the higher pressure will become the superheated steam at the lower pressure. So we cool this steam, okay, so the pressure will increase, it will become the dry steam, then this is the constant temperature, constant pressure line, the phase change will occur, and this again the constant temperature line of the isotherm. So this curve indicates the change of the phase of the steam of the water at the different pressure. So this is on the pressure and volume diagram. Now, a saturation state is a state from which a change of phase may occur without a change of the pressure or temperature. So you will see here this point F and point D, either from the point F or from the point E. Suppose we are taking point F. If from this point F, we are giving heat to the water, because at this point F, the liquid is saturated liquid. It is lying over the saturated liquid line. If we are giving heat to the water, then water will change its phase without changing its temperature or the pressure. So this F is called as the a saturation state. It is called as a saturation state. Similarly, at point D here, at point E here also, because this point E is lying over the saturated vapor line. So at this point E, the steam is the dry steam, dry saturated steam or the dry vapor. If we cool this vapor at this point, then at the constant pressure and temperature, it will change its phase, but it will not change its pressure and temperature. So the E is also called as the saturation state. So this is all about the change of the phase as well as the critical state and the uh, change of phase of the water or the steam on the PV temperature volume and the pressure volume diagram. This is all. Thank you.